Okay, I have come again. Welcome to my channel. For newcomers, my channel is where I do a lot of teaching, a lot of lecture, especially based on renewable energy fuel generator. So, in my previous video, also my connector say that it's better I run the system using a charger from the coil that is more straightforward than using a battery charger 220 volts then recharging the 12-volt battery. That is better I tap from a coil, that I should have a coil that has a direct charging. But in some angle you guys are right, understand, you understand what you're saying. But the reason why using a you can see this statue here is 1.2 1.3 kilowatts. So from 1900, this one is a Tiger. So normally now you can see this yellow wire here is for capacitor terminal, because it is a self-induction generator. So this yellow wire here is for capacitor. Then this red and black wire here is for 220 volts, while this green wire here is for 12 volts charging battery. So let me bring it on. So this is the rotor. This is the ceramic magnet. So now when you want to check this coil here, when you want to, you can see uh, there's no space left. Every space they wind it, so there's no space left here. All the whole 36 slots is occupied. There's no open space. So you can see the output of this generator terminal is 6. And like I said previously, this yellow wire identified as a capacitor. Then this red and black identified as a 220 volt, while this green wire is identified as a charging of the battery. Likewise, this generator. So now this one here only has a 4 terminal. This yellow wire is for the capacitor. Then this red wire is for 220 volts. It doesn't have any charging. So now, in terms of using this system now as fuel generator, so that you can connect your battery terminal with a rectified diode, then tap it on the 12-volt battery. So yeah, it's work. But the reason why it does not recommend it, especially in factory winding, is because you can't charge 12-volt battery with 12 volts. You can't charge 12-volt battery with 12 volts. You can charge 12-volt battery with at least minimum of 13 volts. Because once you use 12 volts to charge battery, the battery will remain 12 volts. So to charge a 12-volt battery, you need at least 13 to 14 volts. Some charger use 14 volts, 14.5 to 15 volts to charge the 12 volts. So the upper the volt with current, the faster the battery charge. And another thing is the negative effect of this is assuming your battery is fully charged, your battery will be still receiving energy from this because it doesn't have any auto cut off. Auto cut off mean once your battery is fully charged, it will cut off, or it will be on floating, so it doesn't receive much or significant current again. So, but running this thing with a bridge rectified diode, you may be getting something about 11 volts, depending on the speed of your generator. Assuming your generator is a self-induction like this model, it doesn't have any AVR to dictate the speed of the volt terminal, trimmer to determine the speed of the generator. You'll be keep having a high voltage. You may have almost more than 15 volts or even 17 volts. So which is very, very dangerous to the your battery health. So I hope you see the negative effects of this using uh, direct terminal from the generator to charge your battery. Yeah, it is very, very simplicity, but what of the current? So because if you check my previous video, the issue I'm having is that the current the motor is consuming is quite higher than the input returning current the charger is returning. But assuming this system will work with direct power from recharging the battery, it is very, very simple. It is like a very efficient because once there is much conversion, there is energy loss. So assuming if this can be run quite alright, assuming you wind more turns maybe so that you will have at least 15 volts or maybe 20 volts, then you will have a controller, then you put it on the input so that assuming when your battery is fully charged, it will automatically uh, go on floating so that your battery lifespan will remain. So I hope you understand. So like those that suggest I should run my system direct from a coil. So you can see this generator, stator generator here. It has a direct charging. This is for capacitor. This is for 220 volts output. But this one here, it only has a two terminal capacitor and the mains. So I hope you understand the reason why. So it has negative effect and positive effect. The positive effect is like it you don't need any buying any charger again, and it will run directly to the battery. But the drawback is that sometimes the output may not be up to 12 volts. It may be something about 9 or the 11 volts, which cannot charge your battery. Or sometimes the output voltage will be higher, which is very dangerous to your battery. So this like a two things. But this one just for capacitor and the mains. So and another thing I want to also experiment here is if you check here, you will see there's no open space. The slot here is a 30 by number. There's no any left space. It's just all included. You see. So why this coil, this stator here, they left because you can see here is for just exciter, this yellow wire, but here is for the mains. 1, 2, 3, 4, 5. It is 5 in number. So putting winding here now and here will result in higher acceleration, which will cause more drag in the generator. So everything has to be calculated. So there's no need winding here for this design, for this setup. And it also tallies with the gauge of the winding and the turns. So it's working hand with hand. So you can see. And another thing I want to demonstrate is when you are winding your generator, don't use aluminum. Don't use aluminum enamel coil. Don't use it. So it has a very very big disadvantages than the advantage. So especially when you want to use it for project, so don't go for aluminum enamel coil. Don't go for it. So maybe some people we want me to explain reason why. In terms of conductivity, copper is more superior. Copper is superior than aluminum. I have said this before. In terms of conductivity, copper is more superior than aluminum. And the small things, aluminum can fade away. Aluminum can get burnt in some temperature or some in working hour. Copper can withstand high some temperature, some amount of temperature which aluminum cannot can't. Oh, and sometimes aluminum, not sometimes, aluminum sometimes fade away. Understand? Assuming you use it is the same capacity, the same size, the same everything. If aluminum can work immediately, aluminum has a surge, which means in some couple of hours on running, especially when temperature hit it, the efficiency reduce, which means the whole wire will be heating up. It will be heating up. So, and another thing again is that aluminum has a high resistance, high ohms resistance. So now here I will show you what I'm talking about. This coil here, I just wind it. It is a decent size of 0.6 mm. 0.6 mm. This one here is aluminum. Why this here is a copper? This here I'm holding in my left hand is aluminum. Why this one is a copper? Enamel coil, enamel wire. So both of them is I wind it 100 tons. This one is 100 tons. This one is 100 tons. The same gauge, the same everything, same diameter. So now the same gauge, the same diameter, the same tons, but let's know the one that has the high resistance ohms. So now this is my meter. Let me shift this coil. This is my meter. So now what am I going to do now? I have to shift it to you can see this signs. It is ohm signs. So continuous reading. So now remember what I said before. This is my copper. This is aluminum. So now let's first of all read from aluminum. You can see. Okay. Okay. Sorry. This is ohms. 2K. So I have to put it on diode. Continuous reading. You can see the sign here, which means when it is together, there will be a sound, beeping sound. This is my showing. So which means it is a connectivity. So now you can see everything is 000. So there is no any reading. So now this is my I want to test the aluminum coil. Aluminum coil I wind. Okay, it is showing 3. It is showing 3. 3. I mean, so now it is now go to 2 ohms resistance. Okay, now let me keep it now. Okay, now let me test the copper. Both of them are the same tons, the same gauge. You see the difference. Now copper is enamel coil wire. It's displaying 1 ohm. 1 ohm resistance. So now, assuming you use this coil now to generate, this one we have more drag. It will have more drag. This aluminum coil, despite that the same tons, the same size, and the same diameter, this you will experience more drag in this generator. Assuming you are using a motor to drive it, you will experience more drag because it displays 2 ohms resistance. Why this copper display 1 ohm? It's like when you bring this copper 2, like when you bring it 100 again, you have the resistance of this. So in terms of, I believe with this experiment, you will understand what I'm talking about. Once people tell me that I have aluminum, it will work better. Copper is uh, more conductivity than aluminum in many several ways. In many several ways. So with this little test I display here, we use it to know that copper is more superior than aluminum, and it is more conductivity than aluminum. So, and you can see with the same tons, it is 100 by tons, the same size of the wire, the same size of the wire. The only thing aluminum is good for is it has a light weight. So if you put it here, it won't even scare much. So, but this copper I'm holding in my right hand has a meaningful weight. So it has a weight. It's like a times 5 of this. So this look like I'm holding a leaf. So copper has a weight. So, but in terms of conductivity, go for copper. Make sure both the armature, and the stator, all is wind with aluminum with the copper. Sorry, with a copper. So, but because this contributes to this, so both of them work hand in hand. So make sure that everything is copper. Copper is more conductivity than aluminum. So which means if I bring these two, I will have 4 ohms resistance. If I bring these two, I will have 2 ohms resistance. So I believe with this little test I conduct, you use it to know when winding it fully, when winding it with aluminum. So you will know the result with this small test I conduct. Winding this generator, including the lotto armature with aluminum, winding the stator with aluminum, figure out the result. Thank you.